Let's finish up this last problem on the 3.06 notes. So we've got CJ pulling a box to the right as shown. We've got a normal force and a force of gravity that are balanced and not shown. The force of friction and the force of CJ's pull are acting on the box and they're shown. So the first thing we're going to do, we know CJ's pulling the box to the right. We're going to circle this force and we're going to circle this force because they are pointing in a parallel direction. We've got both those circled. So then we're going to take a look at what the question's asking us. So is the box's speed increasing, decreasing, or remaining the same at this point? So we can answer this by figuring out what the net force is and whether or not it's moving in the direction of the object of the motion, or motion of the object. So we can say F net is equal to, there's the 250, and then there's a negative 100. So when we add those up together, we get a positive 150 newtons, which would look like, basically, we would say, okay, great. There's 150 newtons pointing to the right. Ooh, that's a weird arrow. That kind of got away from me. Okay, so we've got 150 newtons pointing to the right, and that's our F net. So we know that it's pointing in the same direction as the motion of the object, which means there's positive acceleration, which means the box is speeding up. So we'll write that down. The box is speeding up because the net force points in the same direction as the motion of the object. Okay, that says direction. Now the next part, how fast will the box move after CJ pulls on it for 5 meters? I have to, oh, that's funny. I have to give you guys a little bit more information because I forgot to give you the mass of the box. So, oops. We've got the mass of the box is 40 kilograms. All right. So when we start to answer this question, how fast will the box move? We're gonna turn towards our good friend, E1 plus W equals E2. That's how we're gonna start this. And we look and we say, okay, it's on the ground. We've just got kinetic energy. Kinetic energy at 0.1 plus W equals kinetic energy at 0.2. All right. We've got the 1/2. Here we go. Oh, we've got kinetic energy is 1/2 mv. Nope, wrong way. Squared. Okay. Plus, now here's the deal. This W here is total work or net work, which means we can take the net force and multiply it by the displacement. We don't have to find the work done by friction and the work done by CJ and then add them up. So we can do F net times the D, and that'll be equal to the 1/2 mv. Okay, I forgot to write the subscript in the last one. Oops. 2 squared. All right, let's go back over here. We'll add the subscript in. Okay. Yeah, well, enough. Just add it to the dictionary, whatever. Okay, so we've got 1/2 mv1 squared plus F net times D equals 1/2 mv2 squared. Good news. We've got all of these numbers. I'm gonna put 0.5. The mass is 40 and V1 is 2 squared. Okay. Plus the F net is 150 and CJ's pulling for 5 meters. And that's going to be equal to 0.5 times the mass of 40 times, and then here's our V2 squared. Okay. So we've got this next one, we're going to do 20 times 4. So that's going to give us 80. 150 times 5 is 750. And that's going to be equal to 20 V2, you jerk, squared. Okay, this equals, ooh, I wrote it down somewhere. I don't know where I wrote it down. All right, 830 is equal to 20 V2 squared. Okay, so we're going to divide both sides by 20. Get out of here. Wow. That's a 20. It's good enough. So when we do that, why don't I move over this way? We do that. Ooh. So that we can get rid of the 20. And I already forgot what 830 divided by 20 is. It's got to be 415 probably. That doesn't sound right. No, 41.5 equals V2 squared. And then all we do is we take the square root of both sides. Square root. Square root. All right, and I do know what the square root of 41.5 is. So that means that we get V. Where did that go? Where's my cursor, guys? There it is. We'll move it over. So we get V2 is equal to the square root of 41.5, which gives us 6.44 meters per second. When we think about that, right? So 2 meters per second is walking speed. 10 meters per second is like Usain Bolt speed. 6.4 more meters per second. Okay, so he's clearly running with this box. But hey, who knows why? Maybe this isn't really a box. Maybe it's a suitcase he's running to catch his plane. That's possible. Oh, he's hauling pretty fast there, but that's okay. Okay. So that's our final answer, 6.44 meters per second. That's how we got it. Have a good one.